217 out there. Okay, just before starting, you have to prepare your mindset actually. Just be relaxed and leave everything behind, whatever you have studied, and just think like you are going for any coaching classes for competitive exams. So first, come out from this academic background, whatever the academic background setup you are having in your mind for your regular classes that we are regularly taking. So you come out from this feeling first, and then just free your mind. Like think like we are just going to learn something from the quantitative point of view, and then we will write some competitive exams, and we are here to how to implement the concept in the numerical form and how to solve it quickly. Okay, so the perspective and objective is different here. Rather than going for the conventional studies, you are going to write something, you are preparing for the a subject, and you will be preparing modules, studying a lot of things, and descriptively you are going to write the exam. Okay, and if you don't know the concept also, if you're writing something partially, if you're writing something, there is a step marking, and then you will be getting marks there. So that's a different approach. Here the competitive exams means we are little bit more specific. You must know how to incorporate your knowledge and concept in terms of the question, and how to approach it quickly. More and more you practice in this sector, more you will get the expertization, right? And clearly you can solve it, and time limits play an important role here. Accuracy play an important role here. Bulk of study doesn't make sense. Only quality teaching play a very important role here. So grasping less thing, but with a good quality manner, you can easily clear any of the exam, right? And then, of course, you will do practice with the same uh, objective type questions and MCQ type of questions in various competitive exams, and then you will get practice. You will make mistakes. It's a hit and trial methods. You will make mistake. You will correct it. You have to check again and again your score, how much negative you are going to do it first time. What is your negative positive ratios? Because every question has contain a negative marking. So just like that, you cannot take it. If you are not sure about the questions, if you are completely blank, you don't try to attempt it. Don't even touch that question. If you are confused between two options, there are the four options given. If you are confused like in two options, I'm sure, but I'm not pretty sure which one is the correct here. And then you can play with the statics, probability statics, 50%, 50%, 50%. But that also you do it in last one. The questions which you know very well and you can solve it, you know, from starting to end of this question. Most of the questions are numerical type. So to attempt those questions first, and go to easy to difficult approach. Always it will be easy. Just easy questions you guess first, and then take it, and then go fast. And if you know the particular question, but it takes time for solving, that also you complete it. But don't touch the questions which you are not sure about it, because every question can take your positive marks also. So there's a 1/3 or 2/3 negative marking contains every question. So you have to be very sure about it. Other things about the gate pattern, I want to tell you, all the four options will be very close to the exact answer. Suppose for the particular questions you are getting a settling velocity 2.35. Okay, so the remaining four options will be like this: 2.48, 2.2, 1.89. Like this options will be given. So sometimes if you are making a numerical mistakes in calculation, if you are getting wrong answers, because every questions will be getting only 2 minutes or 3 minutes for solving. Not more than 3 minutes are enough for solving a particular question. So generally what will happen, you will be getting a 3 minutes for solving the one question. So there is a chances that you can make a mistake in calculations, and the physical calculator is not allowed. Only the screen, but there will be the calculator screens. You can open it inside, and then you have to do the calculations. So these are the practice that you have to do it before going for the examination, because until unless you will not practice for this, until unless you will not practice for this digital calculator, virtual calculator, your speed will be very slow. If of course every questions play a very important. You are playing with the time management and accuracy, so you have to understand that. Okay, so we'll start just free now from all the academic backgrounds and just think like you are right now going for the different perspective. Okay, so once you make it free your mind for all the burdens, then you can learn something. Okay, yeah. So this AICT classes, this is GATE classes are initiative for Ministry of this thing, All India Council for Technical Education, and it comes in the it's an initiative given by Ministry of HRD, and then these classes are especially for the SC students, promoting those students for higher studies. Uh, okay, so this is the GATE syllabus. They have IIT Bombay is taking the GATE exam this time. They have done some quite changes over there. It's the biggest national level. I will tell you the background of 2 minutes for this GATE exam. Then I will come for my domain part. Then we'll study about the water treatment plants and the wastewater engineering. Right. So it's the biggest national level exam, entrance exam. It holds a lot of weightage when it comes to space slow. Yeah. Go down. So national level entrance exam that holds a lot of weightage when it comes to decide where you are going to do your higher studies or where you will subsequently do your job. So major PSUs cover under this. So they will directly call for the interviews based on the GATE score. If you're getting a very good GATE score, there is a direct recruitment process through the GATE. They will be conducting some interviews, and after that HR round, and then you will be absorbed as in graduate engineer training. So there's the 18 major PSUs, and then mini Ratna and these public sector there are the two types of categories in PSUs. One is the these like IUCL, HPCL, NTPC. These are coming in a major PSUs sectors, and some mini PSUs are also there. So roughly a lot of jobs options we are having it through GATE. So you can once you qualify with a good score, you can directly apply in these portals, and you can absorb as a graduate engineer training for the permanent job positions. So, and other things, you can go for the master's MTech program for IITs and ISCs and NITs. They will give you good stipend. MHRD stipend will be available throughout the year, every month, and then you can join as a master program. In some foreign universities also nowadays they are accepting GATE score. So GATE score will be valid for 24 months for 2 years. IIT Bombay is conducting this exam, and already people have applied for it. Dates over. It's a fully computer-based exam of 3 hours duration, consisting of 65 questions, total of 100 marks questions. There is the breakup given here. They have made several changes in GATE exam 2021 pattern of questions. The paper of GATE exams 2021 will be completely objective type. The new GATE exam patterns of questions will include a new category of questions, MCQ types. There are 1 to 25 is an MCQ type questions, 4 options will be given, while the remaining questions might include multiple select questions, that is MSQ, and the others are a numerical answer type questions. Numerical answers type questions will not have any options. There will be a slot given there. Once you solve these numerical questions, you have to write the digit only, and by using the virtual keyboard. Okay. Marks distribution among the sections has also changed. Total number, as I told you, 10 questions will be for the general aptitude. There are the 10 questions for general aptitude, 55 questions from the subject domain, in which 10 to 15 marks questions will be related to your engineering mathematics. Okay, and remaining will be the core domain questions. So general aptitude 15 marks, and engineering mathematics 13 marks. Subjective questions containing 72 marks, so total will be the 100 marks questions. Okay. So this time they have increased some subjects also. Number of subjects are 27 sections, and these things we have discussed it. MCQ and MSQ and NAT questions. The questions types, what they are going to test it, their abilities like recalling, comprehension, application analysis, and synthesis. Okay, so based on these abilities, they will be checking based on this GATE exam. The types of questions will be in that manner: recall, comprehension, application analysis, synthesis. So as far as our engineering, environmental engineering syllabus is concerned, we will be having water supply engineering containing 5 to 6 marks, wastewater engineering 3 to 4 marks, solid waste management, air pollution control, and noise pollution control will contain 1 to 2 marks. Okay, this is the your environmental engineering syllabus. So water and wastewater quality treatment, basics of water quality standards, physical, chemical, biological parameters. In the last series, we have discussed about the physical, chemical, and biological characteristics of water and wastewater, and that portion we have completed last time. And we have done the basic water treatment plants or unit operations also. So I will be moving now for the unit operations and treatment part mainly. All the primary, secondary, and tertiary, we can say the biological treatment and advanced treatment methods. So distribution parts also, like how there's a distribution network, how to draw that and all that. If I have a time, I will also discuss about that part. And CV's part, in your regular studies, we are also studying the CV's treatment and wastewater engineering part. So I will try to discuss in from the GATE point of view. Just GATE is not asking everything, whatever you have studied. They will ask the topics and the particular concept they need to check it only. Okay. So your pollution parts and municipal solid waste part doesn't have that much of weightage, but 1 to 2 marks question they can ask it. So this is I will talk later about it. In the last lectures, we were, if you have seen the PPT, we have completed the biological characteristics in which biochemical oxygen demand we have bind up last time. I just quickly go for the BOD because some portion is remaining in BOD. Then we'll move for the our treatment part. Okay. So dissolved oxygen in wastewater for the oxidation of both inorganic and organic matters, demand of oxygen is expressed in two ways. This is total organic carbons sometimes. So biochemical oxygen demand and chemical oxygen demand. And third one is the total oxygen demand also. So BOD is the measure of the oxygen required to oxidize the organic matter present in a sample through the action of microorganisms contained in a sample of wastewater, most widely used parameter of organic pollution for both surface as well as the wastewater. So the strength of the sea waste will be defined through the BOD only. So we can say the oxygen required for the microorganism to carry out the biological decomposition of dissolved solids or organic matter in the wastewater aerobic conditions at a standard temperature. Generally, BOD we are taking a 5 days incubation period and 20-degree Celsius temperature. We are measuring a BOD 5. There is a BOD 21 also. So in BOD 5, we say like 99% of organic matter will decompose completely. So BOD 5 is enough to check how much dissolved oxygen present in a organic matter or in a wastewater. The BOD test that we used to do in laboratory, and the unit is mg per liter ppm. The test for biochemical oxygen demand is uh, a procedure that measures the oxygen consumed by bacteria from the decomposition of organic matter. If I'm talking about the BOD, we are talking about only the organic matter decomposition. And organic matter decomposition will not happen in a BOD case. So how much oxygen is required to decompose the organic matter completely in an incubation period of 5 days and 20 degrees Celsius temperature? That is called as a, this demand is called as a BOD. So change in DO concentration is measured over a given period of time in a water sample at a specified temperature, and determine of approximate quantity of oxygen required for the biological stabilization of organic matter present in the wastewater. And these are the main purposes for the BOD test, why we are going to conduct it. And determine of the size of the wastewater facilities, treatment facilities, measurement of efficiency of some treatment processes. Determination of the strength of the sewage also will be decided based on the BOD test. Determination of amount of clear water required for the efficient disposal of wastewater by dilution. So there is the first stage demand, first stage BOD demand, and second stage BOD demand. First stage BOD demand. Decomposition of organic matter will take place in two stages actually. In the first stage demand, only the carbonaceous matter will decompose, biodegrade. In the second stage demand, the nitrogenous matter, we can say the nitrification takes place in the second stage demand. Okay, so we can say based on this, there is the carbonaceous matter as well as the nitrogenous matter will be presenting in terms of organic matter in the wastewater. So first carbonaceous matter will decompose, and second one then the nitrogenous matter will decompose. That's why we call it as first stage demand as well as the second stage demand. There are some tests for it. The test consisting of keeping the sample of the wastewater in a contact with a definite air or oxygen in a specially prepared vessels. BOD is then measured manometrically. If you have done a BOD test in your laboratory, environmental engineering laboratory, so they are doing it for the 5 days dissolved oxygen content. They are checking it. They are putting a sample for 5 days in a incubation of 20 degrees Celsius temperature, and then after that they are taking out sample and they are measuring the dissolved oxygen. So dissolved oxygen after 5 days and dissolved oxygen initially how much it is, what is the difference, and multiply with the dilution factor. Dilution factor, how much waste, how much sample you are going to dilute with the distilled water. So this is called as dilution factor. So in the morning lecture I have told you A plus B divided by B, right? This is called as dilution factor. So how much will be the DO content after 5 days? 5 days consumption, and what will be the initial DO content? Difference between them multiply with the dilution factor will give the BOD5. Okay. So dilution method, sample is diluted with a specially prepared dilution water. The dilution water is carefully on a neutral pH level. The water is aerated to saturate it with the oxygen before mixing it with the sewage sample. The initial DO of this diluted sample is measured. The diluted sample is then incubated for 5 days at 20 degrees Celsius, as I told you, in an airtight glass vessel, and the DO of the sample is again measured. The loss of oxygen or the oxygen consumed during incubation is then found by calculating the difference between the initial DO of initial content of the DO and the final content of the DO. So DO5 is oxygen consumed multiplied with the dilution ratio or dilution factor. What is dilution ratio? Volume of diluted sample divided by volume of undiluted sewage sample. Okay, the ratio will get. So for exercise, suppose this 1 ml of wastewater is diluted to make 100 ml of test sample. So what will be the dilution ratio? 100 ml divided by 1. So 100 will be the dilution ratio for it. BOD test is performed generally in 300 ml bottles. First stage BOD formulation. There are two stages of decomposition and BOD test, as I told you, carbonaceous stage and nitrogenous stage. Carbonaceous stage, the first stage represents that the portion of oxygen demand in involving into the conversion of organic carbon to carbon dioxide. So in the first BOD demand, what will happen? Carbon dioxide will be releasing. And the nitrogenous stage, it's a nitrification stage actually. Or second stage represent a combined carbonaceous plus nitrogenous demand when organic nitrogen, ammonia, and nitrates are converted into nitrate, and nitrogenous oxygen demand generally begins after 6 days. Okay. So BOD gives a measure on the impact of wastewater on the oxygen content of a receiving sample, stream, lake, and river. And wastes are broken by the microbial organisms, frequently referred as the bugs or microorganisms, and the bugs in turn required oxygen for the monumental efforts. Okay. So there is the rate of deoxygenation and rate of reoxygenation that we have. If you see that in the sewage water, wastewater engineering, the self-purification methods, we were talking about the reoxygenation rate as well as the deoxygenation rate. The same concept here also we have to apply. So at a given temperature, the rate at which the BOD is satisfied at any time is called as the rate of deoxygenating. May be assumed to be directly proportional to the amount of organic matter present in sewage. So we can say as dLT by dt is equal to minus K. K is the rate constant of deoxygenation, LT. T is in subscript here. Okay. LT is the amount of first stage BOD, remaining in the sample at any time t in mg per liter. K is the rate of constant rate of oxidation of organic matter per day. T in time in days. Integrating between t is equal to 0 to t is equal to t. If you integrate it, you will get this parent equation that we have used it in last time. LT divided by L naught is equal to e to the power minus kt. Yeah, you can write it. LT is equal to L naught into e to the power minus kt. So the parent equation that we have used it in our self verification, the same equation. So LT is equal to L naught into e to the power minus kt. You can derive it with the first order integration with the limit t is equal to 0 to t is equal to t if you do it. Okay, and then k constant, if you convert into 10 to the power minus kt, the natural logarithm, then you have to divide this by 2.303, the basic conversion for log 10 to exponential form. So L naught is the oxygen equivalent of the organic matter present in the CVs at the beginning, and K is known as the base rate constant. So exponential to log 10 term, if you want to convert it, K and K dash conversion, you can do it. So amount of BOD remaining at any time t is, you can get it LT is equal to L naught into 10 to the power minus kt. Yeah, you can write it LT is equal to L naught into e to the power minus kt. The amount of BOD that has been exerted at any time t is, that is YT amount. We can say BOD at time t for t days. This is called as the BOD deficit actually. The DO deficit that we have calculated in the CV's self verification methods. No, the same way you can calculate a BOD deficit actually. So initial BOD, and then after time t may be 5 days or 21 days, what will be the BOD content? So deficit you can get it like you have done in DO sec curve. No, the same thing. BOD also, BOD deficit also you can get it. L naught minus LT. So LT you can put it from here in the L naught form. So finally you will get it L naught into 1 minus 10 to the power minus kt, or you can write it L naught into 1 minus e to the power minus kt. So if you want to solve the numerical related to BOD, you will be using these three equations basically. One, this equation, third one BOD deficit, minus it, then you can get it this equation, and fourth one was this, first one was this BOD5 oxygen consumed multiplication by dilution ratio. So this is the first equation that you are going to use it while you are solving a BOD equations or BOD questions. Anything they can ask it. If they want LT value, the BOD after t days, so you have to multiply initial BOD multiply with 1 multiply with 10 to the power minus kt or e to the power minus kt, you can write it. Okay, this equation. And then k dash to k, if you want to get the ratio, so k will be k dash divided by 2.303. Okay, if it is exponential term, then you have to put it, this k value will be given generally, oxidation deoxygenation constant value. If it is not given, then you can convert it. So depend on how you are going to apply this formula, whether it's 10 to the form or maybe in an exponential form. Suppose if you want to calculate the 5 days of BOD, so you write a Y5 initial BOD minus BOD after 5 days, then deficit you can calculate it. So ultimate BOD, ultimate first stage BOD by putting t is equal to infinite. If you put a t value as infinite, then you will get the ultimate BOD that we generally called as L naught. Okay, so ultimate BOD will be L naught into 1 minus 10 to the power minus k multiplication infinity, so it will be converted again into L naught. So ultimate BOD will be equivalent to the initial BOD only. Okay, so L naught, it will become L naught only. So K base 10, deoxygenating constant depend on the temperature at 20 degrees Celsius. That's all. Okay, so ultimate BOD content will be equivalent to the initial BOD actually. So these are the, so once you solve these BOD equations and questions, we'll be having some short questions on that. We can solve it and then you will understand. These are the three formulas you have to apply for the BOD once you get a questions related to BOD. Maybe for the wastewater, maybe for the water supply. Sometimes temperature also, in terms of temperature also we talk the rate constant. So rate constant K also depend on KT. T is in a subscript here. Okay, at any temperature T, temperature will be in degree Celsius. there is Hopf erroneous relationship. Kt is equal to K20. These are all in subscript. Kt is equal to K20 multiply with theta to the power T minus 20 degrees C. That we have already studied in a series treatment plant also, and self-purification methods. The same equation it is. If they are asking a temperature gradient, then you have to apply this. So Q, the theta value will be 1.056 for temperature range 20 to 30 degrees Celsius if the wastewater temperature is in that range. If it is other than 20 to 30, then you have to put this value 1.047. Theta ki value 1.047 or maybe 1.056 you have to put it. Okay. There is a second stage BOD. As I told you, in first stage BOD, carbonaceous matter is oxidized in the first stage of biochemical reaction, and then in the second stage of BOD means nitrogenous matter is oxidized. Though some of the autotrophic bacteria are capable of using oxygen to oxidize non-carbonaceous matters such as ammonia to nitrates and nitrites and nitrates. What will happen in first stage BOD? CO2 will be forming, and the second stage BOD, ammonia will be converted into nitrites and nitrates only. Okay, this process is called as nitrification. Ammonia to nitrites conversion and nitrate conversion is called the nitrification process. Sometimes we have to remove the excess nitrogen also. That process is called as the denitrification. Okay, so we are not going into detail. That much detail is not required. So nitrogenous oxygen demand caused by autotrophic bacteria is called as the second stage BOD. Then this is the curve you see there. This is the BOD, and this is the time in days. This is the 5 days BOD consumption exponential graph, and this is the BOD, ultimate BOD content. We can say ultimate BOD, or we can say the saturated level of BOD. This is the saturated level of BOD, and this is the after 5 days BOD. And to oxidize the carbonaceous matter reaching up to this saturated level, so we can say the carbonaceous BOD it is. If it is nitrogen matter, then we can say the second stage of BOD will start that time. So in the second stage, there is ammonia nitrogen. Nitrification is taking place with respect to bacteria and other constraint, and then nitrite conversion is happening. Bacteria will be producing its number, and then if you see the curve here, BOD and then days, primary oxygen demand and secondary oxygen demand. Till that carbonaceous BOD will take place. After that, the nitrogenous BOD, a second stage of BOD will start. But this is the carbonaceous stage here to here, and then if you extrapolate this, after this, second stage BOD start. Nitrogenous matter start consuming here. Okay. Okay, that was the before the BOD I want to explain. So I left in earlier class in detailing. I couldn't explain. That's why I took time for it. So we'll move for the next portion. Now we'll move about the unit operation, water and wastewater treatments. There are the physical unit operations, chemical unit operations, biological unit operations. If we talk about the physical unit operations, we'll be having first and foremost thing is screening, aeration. Second is aeration. Number third is flow equalization or mixing. I'm talking in combined way, wastewater as well as the water treatment only, municipal water. Okay. So just first I will talk about the water treatment plant, then I will go for the wastewater treatment or sewage treatment plants. Most commonly, what are the processes? There are the three types of processes here: physical unit operations, chemical unit operations, and biological unit operations. In a physical unit operations, physical force predominant, so screening will be taking place. There are some screens, bar screens, coarse screen, and fine screens will be using for capturing the debris and larger particles, larger physical particles, and lot of debris, lot of physical impurities and sand, clay will be there, so we can capture it. So screening. It will be not required for the water treatment, but for the sewage water, screens are required. The intake structure screens has to be provided. because the sewage water is more thicker than the municipal water. Second is the aeration process. It is common for both water supply as well as the sewage water. So aeration, the main reason for aeration, they are using aerators, spray aerators, mechanical aerators, the cascade type of aerators. The main reason for aeration is to provide the atmospheric oxygen, so the excess oxygen can be dissolved or mixed with the water. So as I told you, oxygen is a very good oxidizer. It can oxidize the impurities, organic impurities available in the water, and then it can remove the H2S content and CO2 content in that. So bad odor and taste can be removed through the aeration process. So where aeration can be provided in various ways. I will go in detailing, then we'll talk about it. C is the flow equalization and mixing. So sometimes what will happen, the sewage water is joining from the various streams, right? Suppose area A, area B, different zones. It will be coming in throughout the and outfall sewer finally. So sometimes what will happen, the industrial sewage is also included in that. So the various areas are having a different characteristics in a sewage, because finally in outfall sewer the mixing of sewage water is coming. So various areas sewage water can be, the characteristics can be different, right? So you have to equalize its pH, you have to equalize its concentration, so that it will be easy to treat this wastewater for the further unit operation. So generally there is equalization tank, there is a flow equalization, there is a pH correction tank will be provided, and so that the concentration and pH can be corrected. And once the pH and concentration can be uniform, it will be easy to treat for the further operations, because heavy environmental loads will not happen. Okay. So mixing and circulation के लिए we'll be having various stirrers, mechanical stirrers, and the various mixing tanks, mixing chambers, where because sometimes you have to add a coagulant also, chemical coagulant, for providing the sedimentation process, right? Primary and secondary sedimentation process, coagulant is added. So there's sometimes stirrer tank will be provided. Sometimes we can say the mechanical stirrer is also provided for it. Flocculation, sedimentation, flotation, vacuum filtration, micro screenings, and air drying, these are all the physical unit operations. So generally it will come under the primary treatments only, pre-treatment and primary treatment, all the physical unit operations. Second is the chemical unit operations. Chemical unit operations means you need to add some chemicals, so the process of removing dissolved solids, suspended solids, and colloidal solids will be easy, or easily it can be, because small particles can generate a flock, and then they can come out. If it is lighter in density on the top, they will generate a flock on the top, or if it is heavier in a gravity, it will settle down on the sedimentation tank on the down, right? So it depends. So those various chemicals are added and various chemical processes are taking place. That's why we call it as a chemical unit operations. So sedimentation with or without coagulation can happen in two ways. I will talk in detail later on. There are the chemical precipitation process, gas transfer, absorption, disinfection, combustion, ion exchange, and electrodialysis will come in chemical unit operations. There are the biological unit operations, where the aerobic process. Biological unit operations means the organic matter will decompose in two ways. One is aerobic decomposition, another one is the anaerobic decomposition. So the basic, we can say the reason, or we can say the objective for providing a biological unit operations, to decompose or biodegrade the organic matter, to remove the pathogens and bacteria available in a water through the biological treatment process. There is activated sludge process, there are trickling filter process, right? There is anaerobic digester and aerobic digesters also, you are going to provide it for the biological unit operations. So generally, there are the two processes here, aerobic process and anaerobic process. In an aerobic process, where the atmospheric oxygens are involved, in which the name of the process are activated sludge process for treating the sludge, and then these trickling filters, aerobic stabilization pond and oxidation pond also, we can say oxidation pond, and D will be the aerated lagoons. In all of the process, atmospheric oxygen is sprayed for completing the process, so aeration is required, right? So atmospheric oxygen and other sunlight and other factors are also required for decomposing of the organic matter. So These are the aerobic processes. And what are the anaerobic process? Where the atmospheric oxygens are not involved. Here, some aerobic bacteria will be there because the bacteria which can survive only in a sunlight and aerobic conditions are called as aerobic bacteria. So, aerobic bacteria, sunlight, and organic matter present in water, and of course, the atmospheric oxygen will flourish these reactions. Another one is the anaerobic process. Here, anaerobic bacteria will take place. Bacteria, the microorganism, will help to decompose the organic matter, but the atmospheric oxygen is not available. Partially, very less amount, or sometimes no. Also, it is this process is called as the anaerobic process. So, anaerobic plus digestion, ANSP, ANSD, and then anaerobic contact processes, anaerobic filters, anaerobic lagoons and ponds will come in this range. Okay. There are the unit operations. One by one, we will study about the all the unit operations. Then we'll come for the water treatment plant, drinking water treatment plant. What are the various processes in water treatment plant? How to design a sedimentation tank? How to design aerators? Right? We'll do some subsequent numericals. Then first we'll study the concept. Then we'll do the numericals one by one. Okay. Yeah. These are the unit operations. The principal phase transfer process. One is you have to understand the phase transformation process, liquid to solid, solid to liquid, right? How the gas will diffuse in a air, right? How the gas will diffuse in a water, and how the phase transmission process will take place. So first we'll talk about the phase transfer processes, which is the important process. We'll talk about the gas transfer, ion transfer, solute stabilization, solid transfer of nutrients, and molecular transfer, in which most of these cases we will be dealing in a water, gas transfer and ion transfer only. Okay, so the impurities are negatively charged. If you are adding coagulant in that, right, that will be positively charged. So the neutralization will take place, and then physical and chemical sedimentation will take place. So like this. And if you are going for the aeration, gas will be dissolving, diffusing with the air, and how it will dissolve oxygen that you are adding it from the atmospheric oxygen from the atmospheric areas, right? So following are the operations, which constitute the physical, chemical, and biological unit operations employed in water and wastewater treatment. One is the gas transfer. The important process is aeration in that. The second is the ion transfer. And ion transfer, chemical coagulation, chemical precipitation, and ion exchange and adsorption will take place. These are the ion exchange process: chemical coagulation, chemical precipitation, ion exchange, and adsorption. Absorption is different, adsorption is different. Adsorption is a surface phenomena. Okay. Solute stabilization. In a solute stabilization, we will be talking about the chlorination, liming, recarbonation, superchlorination, all that. And then solid transfer, straining, sedimentation, flotation, as well as the filtration will come in solid transfer. Fifth one is the nutrients or molecular transfer, where nutrients will transfer, like a nitrification and all that, right? Interfacial contacts, and then seventh one is the miscellaneous operations: thickening, centrifuging, chemical conditioning, biological flotation, vacuum filtration, air drying, heat drying operations, sludge digestion, and incineration, right? So these are the all processes which will take place in a water treatment and wastewater treatment. Now we'll talk about the water treatment plants, how the water treatment plants work for the surface water treatment as well as the groundwater treatment. What are the unit operations that will be applicable? This is very easy because we have a certain time limit, so I'm a little bit fast, but it's kind of revision for you because you have already studied, so don't take panic for it. Okay. So let's start from the, suppose we have a surface water body. We have a main source of water through the surface like lake and water stream. So there will be a dam where water is coming through the intake structures, all the conduits and pipe network. And there will be the intakes, complete intake structures where There will be intermediate pumping stations also sometimes. So the surface water quality characteristics are different from the groundwater quality characteristics. So based on this, you have to change the unit operation. As I told you, water treatment will be decided based on the quality characteristics only. So you will be having a surface water, you collect the sample, test the physical, chemical, and biological characteristics. Based on this, you can propose the treatment. So generally, then in general way, if it is a surface water body, what will be the unit operations that you have to provide it? Number first, there's the raw water. You have to directly send it to the for the plain sedimentation without coagulation. Okay, so suspended particles can be captured in a sedimentation process. Then second will be the coagulation, the sedimentation with coagulation. So you are adding coagulant in this, maybe alum and ferrous sulfate and all that. And then chemical precipitation and sedimentation will take place. Colloidal substances can be captured here. It will generate a flock on the top, or maybe the heavier particle will settle down due to the gravity settlement. So in a settling tank or sedimentation tank, in the form of sludge, we can segregate it. Fourth one will be the filtration process, in which the dissolved organic components can be captured, can be removed it. And fifth one will be the disinfection. So these are the five processes will be taking place in the surface water treatment plant. Okay, and disinfection purpose, as you know, we have to remove the infectious pathogens, microorganisms, and bacteria to make the water safe for drinking. So generally, the disinfection purpose, we add chlorine. There are various chlorine doses, and you are going to add chlorine in two phases. One is the pre-chlorination chamber, and another one is the post-chlorination chamber, right? So two times you are going to add the chlorine, and chlorine is a very good disinfectant. It will kill all the pathogens and bacteria, and then water finally will be ready for drinking. There will be a clear water reservoir, and there is a distribution network. You can supply the water for the drinking purpose uses for the domestic consumption. Second, if it is a groundwater treatment, so you have to provide the aeration first for the groundwater, because there is a lack of oxygen in a groundwater. Water we are taking from the groundwater aquifers and water table. So aeration is required, because aeration, as I told you, dissolve more oxygen in a water. You can spray oxygen, you can diffuse oxygen through the aerators, cascade or mechanical display types of aerators. So undesirable dissolved gases like H2S and CO2 can be removed it. And aeration also help to control the iron content and iron and ferrous content in water, and magnesium content also. So it helps to make a magnesium oxide, Mg will again react with the oxygen, the MgO2, and we can say that if it is iron also, those then Fe3 and Fe3 or Fe second, right? So it can oxidize it easily. So to removing the magnesium and iron content also aeration help. The major reason for aeration is to remove these noxious gases like H2S and CO2. The third process is water softening, because the groundwater generally is hard. It's having a calcium and magnesium present in that, and it's having a carbonate and bicarbonate present of calcium and magnesium, as well as the sulfate and chlorides are also available for in that. So maybe the water can be hard. So hardness can be removed in two ways. We have a If it's a temporary hardness, you can go for the boiling and all that. If it's a permanent hardness, you have to go for the lime soda methods, and various methods are there for removing a permanent hardness. So water softening is also required. It depends what is the content, what is the value of the hardness in ppm or mg per liter. If the major portion is related to permanent hardness, then you have to provide the alternates for the permanent hardness removal methods. Otherwise, simply you can remove it. There is a temporary hardness content. Then finally, we'll go for the filtration, where the slow sand filtration or rapid sand filtration bags will be there, and you can remove the colloidal solids and some part of bacterial components also, you can capture it. And then finally, we'll go for the disinfection. Pathogens, bacteria, microorganisms will be removed, and then water is ready for drinking. So these are the unit operations for the surface water body and groundwater body. This is a drinking water treatment plant where screening is followed. Starting operation is the screening. Before screening, there is a Pre-chlorination process, where the some amount of chlorine is added here because water will travel throughout the whole structure. So there is a chances these bacteria and pathogens can create a problem for all kind of chemical and physical treatment. So that's why the some amount of chlorine is added here. Then screening is done here. Screens, suppose it's we can provide screens, fine screens or core screens. Then there's the ozonation process. They have done it here. This is the aeration actually. They're going to provide aeration here. And here this is a flash mixing chamber because before sending this water through there are the orifice yeah, where over where they are connected here to check the overflow rate to check the how much water you are sending in the sedimentation tank या clariflocculator tank. So here before that, because it's a sedimentation followed with coagulation. So coagulant you cannot add in this chamber. This chamber means this is a clariflocculator. So before that you have to make the intermediate tank that is called as a chemical tank or sometimes called as a flash mixing tank. So in flash mixing tank the chemical doses are called coagulant doses will be added. Coagulant maybe alum or ferrous sulfate, various types of coagulants are available. Once you add it, you have to mix it thoroughly because you need a uniform concentration that coagulant should mix properly. So for that purpose, there are the mechanical stirrers or there are the motored operated strainers are required. So it will stir these reactors will rotate in two directions and then it can mix the coagulant with uniform proportions in this water. So once it is mixed, you can send this water to the clariflocculator, and the clariflocculator mechanism will talk later, right? Or the clariflocculator, and that how the coagulation and flocculation takes place, how the chemical and physical sedimentation will take place. Then after that filtration, there are the various labels of sand in gravels, and maybe the slow sand filters and the rapid sand filters. Two types depend on the application. And side coal in gravels they can use it. Water can be captured. There is a detention time you have to provide here. Detention time you have to provide here, and then finally water will be treated. And here the post chlorination will be done. Once the post chlorination completed, you can send it water for the we can say for the clear water reservoir. And backwashing is required for filtration mechanism, as we have told you in earlier concept. So backwashing is the cleaning of the filters from the bottom. So water will be sprayed from the bottom. So because what will happen, these bacterial components will create these voids available in these gravel beds, right? And the impurities, suspended solid, dissolved solids, impurities also will fill with these voids, and then the water cannot be filtered properly. So we have to mechanically clean these filters, gravel filters. So for cleaning that, we use the fresh water. And once you clean this, once you spray this water will become a waste, and this wastewater will be recirculated again through this closed loop. Okay, the wastewater coming out from this, you can use it for the again for this. And this here through the chlorination, they are again going for the ozonation process. Sometimes it is required, sometimes it is not required. This is the wastewater. This is the water which is coming out in the cleaning operations of the filter, and then you are again treating it again, supplying water from the screening operation, from the starting of the operation only, screening, rapid mixing, and all that. So it's a kind of recirculation, reclaiming wastewater. Drinking water treatment, there's a case. We'll start the process same, but there's a more clear visualization, so you will understand it. We start from the pre-chlorination, then aeration, then coagulant mixing chamber, that is called as flash mixing chamber. Here flocculators and motor operated stirrers are mixing the coagulant in a water in a uniform concentration. After that, there will be a clariflocculator. Okay, clariflocculator will be having the pedals operated, these scrubbers. The scrubbers will be rotating. Here motor is attached. There is a pathway on the top, so the man can go on the top, and if some problems are coming in the motor in this mechanical structure, we can repair it. These scrubbers are having a rubber tabs. Is it not visible with PPT? PPT is visible. Oh shit.
Now it's not visible, sir.
Yeah, just a minute. It will come. Yeah. If my voice is not coming sometimes, if the PPT is not visible, please let me know because I made a full screen. I cannot see what is going on in the chat box now. Please let me know. Now you can see PPT?
No, sir.
No? Just a minute. Just try and hide this again. Yeah. ठीक है अभी आ रहा है तो
आ
ये
रहा है
वाटर
सर.
ट्रीटमेंट प्रोसेस है मैम या starting from pre-chlorination, aeration, the cascade type of aerators is provided, flash mixing chamber, clariflocculator. Here the pedal mechanism, steppers are provided because what will happen, this interior surface now, once this coagulation process, flocculation process will take place, all the sedimented particles, all the suspended solids will stick with the walls, interior wall of this surface. It's a circular types or rectangular type. So most of the cases it's a circular types of clariflocculator. So in this interior surface, I need to clean this these walls, right? So for cleaning that, I cannot do it manually, and the person I cannot send it again and again. This is not safe because it's a drinking water. So contamination we don't want. So what will happen? This mechanical arrangement has to be there, and this mechanical steppers are having a rubber pads, and it keeps rotating because motor is this driving force is the motor running by with AC current, and then it keeps rotating, and the scrapers will take away all the suspended and colloidal particles which will stick with the wall, and then finally the heavy gravity settled particles will settle down on the bottom in the sludge tank. Sludge tank is also incorporated with it, and then finally sludge will be separated out. Okay, then sludge treatment we have to do it. Here the sludge treatment they are going to do it. Sludge is collected here, then sludge transfer through the pump because it's very thick, then pumping is required, and there is a sludge thickening tank and sludge drying bed where the sludge treatment is required. That is the other part. Then sludge has to be treated, and then you can use it for the manure operations and for as a natural fertilizer you can use it. After calculator, water has to here the overflow weir or orifice is attached to measure the flow rate in an open channel. Water is coming through the down, it will be sprayed from the bottom. Okay, like this. So from there, water is going to the rapid gravity filters, rapid sand filter or slow sand filter, where as I told you, the various types of gravel beds are attached. After that, you can go for the ozone treatment or you can go for the chlorination, post chlorination. So both are disinfectant. Ozone is also very good as disinfectant, and chlorine is also very good disinfectant. So if you want to go for the ozonation treatment, you can go for ozonation or you can go for the chlorination. After that, water will be treated 100%. It will be stored in a clear water reservoir, and then water can go for the distribution, respective distribution network. Generally, screens are not provided in a water treatment plant, domestic water treatment plant, but the screens are provided in a sewage treatment plants. So because we are talking for the both in combined, so just I will briefly about tell about the screening. So to remove all the floating matters, debris, sticks, leaves, branches from the surface water, intake points, water contains suspended solids, silts, clay, sand, everything causes turbidity. So we have to remove that before sending the water for the treatment. So two types of screens we have to provide it. One is a coarse screen, sometimes called as a bar screen. Second one will be the fine screens. So bar screens, a bar grills to stop the grosser floating materials, generally 25 mm in size, and are placed at 75 mm to 100 mm. Inclined position stress slacks are used in dams often and other intake structures. And sewage treatment plant, it is quite common to use these coarse screen by bar screens. For the purpose of cleaning, slope of 3 to 6 vertical to 1 horizontal is provided. There are some mechanical cleaning mechanisms. So mechanically a semi-automatic mechanism are there. So the screens are automatically cleaned in a rotation basis. Okay. There are some drums operated things are also there, and drum will be rotated, and then screens are toppled again and again. Okay. There are the fine screen also. There are second types of fine screens. Surface water intake mechanically strained or cleaning required. Drum or bend with hole of 6 mm diameter. Automatic straining is required. Self-cleaning and continuous work. So you see there, this is a rotation, chain pulley kind of mechanism it is. So it keeps rotating and it takes all the debris and solid particles as continuous chain scraper, wrecking pins, automatic cleaning devices. So nowadays, very advanced screens have come into the seaways as well as in the water treatment also. So no need to, there is no human interference. It will automatically clean it. It will automatically separate all the solids and debris particles, and it will automatically clean also by its own. These are the mechanical screens in a sewage treatment plant. You must have seen somewhere in a drainage system and all that. Okay. So mechanical cleaning bar screens are how the this is the pulley chain mechanism where the gearbox is also attached. So RPM is controlled and it keeps rotating and toppled. So this is a chain driven screens and this is a continuous belt screens. So the conveyor kind of mechanism will be there in that and automatically it will clean the devices. We'll come for the aeration. Aeration is very important phenomena in both water supply as well as the sewage water. It's a process of gas transfer, as I told you earlier. The aim of aeration is to create extensive new and self-cleansing, we can say self-renewing interfaces between air and water. The purpose of bringing water and air into close contact in order to remove dissolved gases such as carbon dioxide, and to oxidize dissolved metals such as iron and magnesium, as I told you. Objectives are clear. It removes the taste and bad odor caused by the gases due to the organic decomposition. It increases the dissolved oxygen content of the water. It removes hydrogen disulfide and CO2 and odor is removed. Decreases the CO2 content of the water, reduces the corrosiveness and raise its pH value also. Okay, so there are various advantages for this aeration process. It helps in chemical precipitation. It helps in physical sedimentation also, right? And for the next process. It converts iron and manganese, as I told you, from their soluble states to the insoluble states so that these can be precipitated and removed easily. Due to agitation of water during aeration, bacteria may be killed to some extent, so it helps in diffusing compressed air. So it can also be used to remove the volatile organic components in the water. So there are the various advantages for the aeration. Okay. There are some aerators which are used for doing this operation. So aerators are divided in three types basically. One is the free fall aerators or gravity type of aerators, generally in which cascade aerators comes into the picture, inclined apron aerators, flat tray aerators, and gravel bed aerators. You have trickling beds will be coming into the free fall aerator condition. Yeah, gravity types of these all types of all aerators comes into the gravity types of aerators. Second is the spray aerators, and third is the air diffuser basin. So these are the gravity aerators, some cascade and cone aerators, spray aerator, diffused air aerators, and then mechanical aerators are also there. These are the aerators that they have provided here. This spray types of aerator they have provided it. Of course, blowers are required to compress the air, and then the air will be coming with the high pressure. It will be diffused in the water. And here, this is the cascade type of aerators. From the bottom, you are going to supply a water with the pressure. There will be a pumping pump attached with it. So water will be coming from the bottom of this peripheral pipe, and water will be coming on the top, and water will spray with the pressure. And there is a cascade, means there are stairs. So more area, if water is traveling with the more time in a more area, what will happen? The more oxygen will be dissolved and diffused. Same concept, water is traveling from the cascade from various stairs. It takes time. The water will travel from here to here. It will take time, of course. The atmospheric oxygen during this time will be dissolved in that. Okay, this is the main perspective for it, main reason for it. So, what are the factors affecting aeration? Change in concentration with respect to time, So this is the common equation, dC by dt is equal to Kg into Cs minus Ct. Rate of gas absorption. Cs and Ct are the saturation concentration of gas in water at a given temperature. Ct is the concentration at T, and Kg is the rate constant of gas absorption. Rate of gas absorption, Kg proportional to area divided by volume, area of interface per unit volume. So we are talking aeration is a gas transfer process, as I told you. So this is the basic phenomena for the, is the Henry law. No, the same Henry law will be applicable for the gases. Same concentration with respect to time is changing. So this equation will be valid for it. There are the design of various aerators. The problem with the aerators are supersaturation, algae production, clogging of filters sometimes, and energy overuse, because for the pumping energy is required. So this is all about aeration. That is enough for it. Okay. They don't ask question on aerators, so I have not covered it. Sedimentation is very important. So moving for the sedimentation part. Sedimentation is achieved in two phases. One is the plain sedimentation. Second is the sedimentation with coagulation. Sometimes we call it as the clarification. This is. So we'll talk about the primary sedimentation here. First unit operation to capture suspended particles from water, removing suspended solid particle by gravity settling. Sedimentation tanks are designed to reduce the velocity of flow of water so as to permit suspended solids to settle out of water by gravity. And what is plain sedimentation? When impurities are separated from the suspended fluid by action of the natural forces alone, maybe most of the cases gravity settlement, I guess would be the gravitational forces, and then natural aggregation of the settling particles. The operation is called as planned sedimentation. Okay. So generally most of the cases through the gravity settlement, through the gravity, all the heavy particles will settle down in the bottom of the tank, and then we can separate it out as a sludge. Plain sedimentation is not too effective because the colloidal substances cannot be removed from the plain sedimentation process. So to removing the colloidal substances, we need to go for the coagulation, that is called as chemical coagulation. So that's why coagulant is added. So sediment with coagulant is more effective than the plain sedimentation process. So we call it as a clarification. So when chemicals or other substances are added to induce or hasten aggregation or settling of the finely divided suspended matter, colloidal substances and large molecule, the operation is called as sedimentation with coagulation. So there is in sedimentation two processes will take place. One is the chemical precipitation, and second one is the physical sedimentation. Okay. So chemical sedimentation, chemical precipitation is nothing but the generation of the flock is called as the chemical precipitation because of the chemical reactions taking place. The negatively charged particles and positively charged particles will make a neutral solution, and the lighter gases and lighter particles, lighter weight suspended solution, dissolved solids will be coming out on the top, not dissolved, colloidal solids will be coming out on the top, and they will generate the flock on the top layer of the water in the clarificator. So this is called as chemical precipitation. झाग जो बन जाता है ऊपर वाटर के जो फ्लो होता है, right? Second is the physical sedimentation is nothing but all the heavier particles will settle down due to the gravity settlement, and it will deposited at the bottom of the tank, or sometimes it will stick with the wall of the interior wall of the sedimentation tank. कहाँ बात की थी हमने इस बारे में? यहाँ पे तो ये स्लज होगा, ये फिजिकल सेडिमेंटेशन है, एंड फ्लॉक ऊपर होगा, दैट इज कॉल्ड एज केमिकल प्रेसिपिटेशन. Okay, so two processes. We'll talk about all those things in detail also later on. Yeah. Now discrete particles, a particle that does not alter its shape, size and weight while settling or rising in a water is known as a discrete particle. Once we go for the zone of the settling, you have phases of settling, phases of sedimentation. So there is one discrete particle settling, zone 1, zone 2 like this, settling type 1, settling type 2, settling type 3 and settling type of 4 that you have studied in water supply and treatment engineering. So then you understand what kind of impurities will be removing in what stage, what type. So in type 1, what kind of impurities will be removing, type 2, what kind of impurities will be removing. This process will go in a stepwise actually, the coagulation process. So these are the types of settlings. Process may settle out of a suspension in the following four ways, depending on the concentration of the suspension. Type 1 is called as the sedimentation, called as discrete settling. The discrete particles will settle down. Type 2 is called as hindered settling. Type 3 is called as a zone settling. Type 4 is called as a compression settling. I will talk later about all those things. Just you must remind here that these are four types of settlings are there. So in detailing, I will go later on. As I told you, discrete particles are in suspension of low concentration, free settlings, and the particles have the latent tendency to flocculate. Now, also we come for the settling of a discrete particles. Please note down the equation. I will go one by one. Please note it down. We know 5:18 now. 6 o'clock will wind up the session. Whatever till that, how much we can cover it, we'll see. The next class then we'll cover. Okay. So the particle is suspended in water. It initially has two forces acting upon. One is the force of gravity. The equation is given here. Fg is equal to rho p. P सबस्क्रिप्ट में है. ये ऐसा लग रहा है multiplication. It's not a multiplication. Rho p actually. So rho p into z, the gravity constant, multiplication with vp, velocity of particles, right? So this is equation number 1. This is called as force of gravity. Number 2 is the buoyancy force. This force of gravity will be towards downward, downwards toward the bottom of the tank. It will go, and the force of buoyancy will be upward direction. So flocculation, right? So quantified by Archimedes law, Fb is equal to rho into z into Vp. This will be in the upward direction. Then you have to balance the buoyancy force with the force of gravity. So a net force is exerted and the particle is accelerated in the direction of the force. This is the principle of Archimedes, right? So there is the force of gravity downward direction. There is a buoyancy force which is in upward direction. If you want the net force, the particle will accelerate in the net force direction. So which one is the larger in that? So force of gravity suppose larger है तो Fp minus rho p minus rho into z into Vp. So if it is coming towards downward, so F net force will be towards the downward direction. So all the particles will try to accelerate towards the bottom of the tank. This net force becomes the driving force. Settling velocity of discrete particles, Vs, yeah, we can say the volume of particles. You can get it pi by 6 into dq. It's a circular tank, pi by 6 into dq. D is the diameter of particle. So volume of the particle, over summation of all the particles, integrate you have to do. Okay. So once the motion of the particle initiate and particles, the Newton's law of motion, this equation, Fd is equal to Cd into AP rho to V square by 2. Write this equation Newton's law. This equation first, second, and this net equation, and this side is Newton's law, this equation also. CD is the drag coefficient. AP is the projected area of the particle. So drag force you are going to calculate it. So force of gravity, buoyancy force, and drag force, third one. And this drag force is equal to the driving force. So this is the driving force. It should be equal to this drag force. If you it, you balance this equation, you will get this result V square. So velocity of the discrete particles you will get it. Finally, you will get this number. This is rho. मैंने R लिख गया इसमें, ये rho है. You balance this equation and V square you can take it. If you want to V square, you take everything there and that side, and then you can get the answer. So 4z by 3 into minus rho into d divided by cd into rho. So that will be the final equation. So you note down all the equations, then we'll move further. This concept is called as settling of discrete particles. So note down this equation and break. वही चीज किया है जो ये नीचे जो आंसर निकाला ना, सेम थिंग हमने यहाँ किया. F net is greater than or equal to Ft. So F net force we have equalized the direct force and we got a Vs square here. So Stokes law of settling velocity. This law is called as the Stokes law of settling velocity. 4 by 3 into z, rho p minus rho into d divided by cd into rho w. Rho is the mass density of water and particle. Okay, sand particle. Now we'll go for the Reynolds number. This is Reynolds number. R is equal to rho upon mu. Hydraulic is studied. On mu may write it 4 divided by mu. Yeah, mu divided by rho. If you can take mu divided by rho, you know, uh, the video on new, right? So open flow, first number, the open channel flow less than 500, and then for flow is less than 2000. The range will be, so based on this Reynolds number you can calculate it. It is not required that much. I'll just go for the conclusion directly. So this was the equation that you have derived it one. And CD value for the laminar you will get it CD is equal to 24 by RE. In open channel flow you have studied those things, same thing. If it is a transition flow, it will be CD is equal to 24 plus 3 divided by RE to the power 1 by 2 plus 0.34. So for the transition flow, you have to use CD value this, and for the laminar you have to use this, and for the turbulent you have to use directly 0.4. So note down these three values. RE is the Reynolds, that is called as rho VD upon mu. Don't see there, directly go for it because I don't want to make you confused, right? Make it easy, the things. One laminar flow, while the value is greater than 10 indicates the turbulent flow. Intermediate values indicate the Stokes law. For laminar flow, terminal velocity equation in the form also. Vs is equal to, एक मिनट, कुछ नहीं, rho vd upon this है ना, rho vd upon mu, you have replaced it, that's all. So this is called as a stock actually. The various applications we are having in engineering, and there are some small numericals on this. So settling velocity of discrete particles, you will get it through the Stokes law, that is E. Z into rho p minus rho w into d pk square particle diameter divided by 18 mu. Called there are some certain numericals. So numerical we will do it and we'll move further. So flow get yeah, these two equations I have to use. Yeah. So here Series for the laminar is given 24 by RE, and RE usually written as the rho VD upon mu. So if you solve it, and if you get the value of Vs, Vs का value you put it from the earlier equation. This Vs value, rho VD, no? Vs value put it from the earlier equation. This one, this one. So you put it in this equation, you will get this is called as the stock equation. So if you want to derive this stock equation, you want to derive it. So final result this will be how put these all the values. This Vs value if you put it here, then you one. So Vs you can treat it, and finally you can write it in mu also. You can write it in u is equal to nothing but mu by rho. Okay. There's one another iteration that is for Vs, which is called as Hazen equation for settling velocity, which will be equal to into s minus 1 to the power d square into 3t plus 70 divided by 100. And Vs should be in mm per second, d should be in mm, t should be in degree Celsius. Write this equation also. Write this, write this also, and if you want to write new form, so rho you have to take it down, mu divided by rho. Mu divided by rho will be replaced with the nu, the kinematic viscosity. And this will be the third equation Vs. So if the diameter of particle is less than zero, is coming under the limit 0.1 to 1 mm distance in between, you have to use the settling velocity equation, this equation, that is Hazen equation, you have to use it in that condition. Temperature will be given degree Celsius. All values will be in mm per second. Vs you will get in mm per second. D will be given in mm only. And then finally you can get it. If D is less than 0.1, then you have to use this equation. So all things you don't need to utilize it, but while you are doing the practices, you must know which equation you have to derive. In the gate exams, that much questions will not come. Simply, they will give one equation. They will give the numerical in which they can ask the VA by using stock equation simply. They can ask CD also. Uh, how you will get the CD. For laminar flow, RE is given that much. Calculate the CD. For laminar flow, the water mass density is you know that, and then V also given, and then you can calculate it. So simple things they can ask you. If they are telling you that D is given 1 mm, and then that so 0.1 L D divided by V is equal to D square. That volume of the particle, no, always dq. So that way you can get area. If it's spherical particle, then you have to go in that way. Then most of the cases it's a spherical only. So generally simple things they can ask, but because we are preparing both, you must know that because coagulation and sedimentation play a very important role in the competitive exams. You have to know that thing. Okay. Very simple question. Finding velocity of 0.02 mm diameter particle with S value. S is the specific gravity, that is 2.65. Settling from the water. Coefficient of dynamic viscosity of water is given 10 to the power minus 3 Pascal per second. So we can ask directly velocity. So which equation we have to stop equation. So so you have to this formula for this equation. So 1 Pascal into second is equal to होता है 1 meter into second. Yeah, you can write 1 Newton to second per meter square. Is so this conversion you may be very keen against the these things. Unit conversion. So how to convert Pascal into the then you may discuss you ask for that. So you will get very
Sir, we can't hear you. So you're not audible. Sir, we can't hear you.
Yeah. So there's a disturbance. Now continue. So the removal mechanism of a sedimentation tank. There's a gravity separation. There's a filtration also. Screens, granular media, and porous media. There's a flotation. There's a fractions which will come on the top. Will generate a flow. So you see here. There's the overflow channel. There's where you can say the orifice we have attached here, and rapid mixing is happening. Pedal flocculator. Sometimes in flash mixing it is happening. Sometimes in the flocculation chamber itself. So and there is a buffels attached with this. So we'll go in the detail about it. Solid physical characteristics, particle specific gravity and particle size distribution. The two things are there. We are dealing with the particle size distribution as well as the particle specific gravity. Okay. So if you see the design part of the sedimentation, there are two types of tanks we will be talking here. One is the fill-in draw type, another one is the continuous flow type. The continuous flow type is having the two types again, horizontal flow type and major features, tank cross-sectional area, tank depth, and type of cleaning mechanism required. In a specifying or design basins for the water and wastewater sedimentation tank, three conditions are commonly used. One is the solid handling capacity, that is kg per day, overflow rate, liter per minute per meter square, and there is a detention time. What happens in a sedimentation tank? You have to provide a detention time at least 3 to 4 hours in that range. If it is a sewage, then more time you have to provide it. If it's a domestic drinking water, municipal water treatment plant, then 2 to 4 hours detention time we have to provide it. We have to hold the water for a particular time duration in a sedimentation tank, so the sufficient time will get it for the chemical precipitation and physical sedimentation process. So basically, we are providing a time for the chemical reactions, the coagulation and flocculation. So whatever level the floc will generate on the top, it will take time to come up. The sludge, the what we call the sedimented, these particles will grow in size. These all the impure particles will grow in size because of the chemical reactions, and it will become heavier in weight, and it will settled in the down, right, in the tank. So these whole process will take time. That's why we are providing a detention time for this. We cannot go in a continuous runoff. Okay. So additional design data required, mechanical construction, other than detention time, these are things are also required. The mechanical construction like a mechanical scrapers are required. Specific gravity of the solids you have to study, size distribution of the solids, underflow constructions, the sludge tank and the sludge overflow, and the sludge treatment tank also, like the sludge dryers and sludge, we can say the thickening operations. We have to provide the various operations on the bottom of the tank, and then flow mechanism also you have to provide. Operating temperature and geographical locations also you have to study it while you are proposing a treatment unit. This is a settling basin, rectangular type of settling turbulence. Inlet is there's outlet. Effective settling zones. In the sedimentation tank, top of the zone is called as a settling zone, where the chemical precipitation takes, and sludge zone where the physical sedimentation of the particles will take place. So sludge will be coming on the bottom, precipitate lighter materials will be coming on the top. It will generate a flow. Okay. Their flow also, that will talk later, all the design concerns and criteria, how to design a sedimentation tank, then how to get the value of overflow rate, how to get the surface flow rate, and all that I will talk later. So this is the overflow rate. How to get the overflow rate? You write this equation. Overflow rate is equal to आराम से लिखो, है ना? The next class you will continue quickly. Okay. So how much we can complete, that's fine. And don't take like a regular class as I told you in the initial starting of the class. Don't take panic. You learn little, but with a good efficiently you will be able to learn the things with accuracy and with the it should go directly in your mind and you can easily solve the answers. Okay. The GATE exams test fees in Prince Academy and Made Easy and then ACE Academy also. They giving the test. They are charging only 400 or 800 or 1200 only. They will be giving a 80 question papers, a 40, 60 question papers. So every day in a week in a 1 week you can attempt one question paper also actually. So you have to open their portals in 3 hours duration. There will be the mock test for the gate. It will be for the gate pattern only, and you have to check the accuracy, how much strong you are, how much accurately you are attempting it. So you will get practice for the gate exam. Okay, so it's a practice. Without practice, the gate exam will not clear. So take the test series, online test series, you join it. Okay, so write it. You have written. Now we'll go next. The types of sedimentation basins, a tank or clarifiers. We having a two models here. One is the basin model. Called we have to check the horizontal velocity of the liquid flow here. There are the mainly used models are rectangle shape or maybe in circular shape. So circular types of sedimentation tank, rectangular type of sedimentation tanks are most commonly used. Okay. So this is a settling velocity profile. This is the height of the chamber and rectangle suppose, and this is the settling velocity. And then you can go the gradient for it. This is a slope gradient, and then that will I will use later. Huh? You just understand how the things are going on. This is you can see the side view of a tank. This is a settling zone. Water is coming here in. There is a effluent weir. From here, water is going towards the filtration chamber or filter unit. There's a perforated vessels here, and there is water is coming here, and this is the inlet zone. This is the sludge zone, and this is the top of this settling zone. Okay, so you will get the here also. Yeah, here you will get more picture. Okay, so this is the circular basin. There are two types of tank we are talking: circular types of sedimentation tank and rectangular type of sedimentation tank. If I'm talking about the circular basins, so this will be double layer. There are the two constructed tanks actually. One is perforated, another one is the outer tank, and water will be circulated here. All the flock material will be circulating here. Okay, and there are the scrapers in the bottom, and from here perforated pipe is in there. Pipe is involved. Water is coming. Water is joining from there, and then it will come up. And this tank, there's a clariflocculator actually अंदर का portion flocculator we called as a flocculator, bahar wala we called as a clarifier. Okay, so there are the two tanks actually here, so clarifier as well as the flocculator. So inside flocculator, outside clarifier. So this is the sludge outlet, sludge portion. This is the effluent channels, inlet and outlet. Outlet water will join to the will go to the filtration chamber. Inlet zone and outlet zone. I'll move further. Yeah, this is the actual clariflocculator, circular type of clariflocculator. All the parts we have explained here. Sludge discharge at the bottom. Sludge will be accumulated here. These are the scrapers. This is a perforated pipe. This is the, we can say, the channel where the person can go and repair the parts here. And there's a kind of a stair structure. It keeps rotating actually through the induction motor operated bridge we have provided here. Scum box with beach plate, scum outlets, skimming. These are all the mechanical and civil parts for it. The steel wall effluent will be coming out here. Scum buffle, because I have to remove the scum and flocks from the top, no? So removing that, these scrapers are keep rotating, and this portion keep coming up and down. So it's having rubber pads on the bottom, and then it can revolve. It keeps rotating, and it can take everything, all the solids, it can remove it and it can send to the sludge tank directly. Okay. Yeah. So we'll go next. So I'll just there are the steps of sedimentation tank. If we have studied, we have a rectangle type, we have a circular type, and we have this hopper type. So there are the various civil structures. So based on the civil structures, we have three types actually. This is a hopper type of sedimentation tank, and this is rectangular clarifier actually. In the rectangle clarifier, the mechanism will be different for removing these solids. And this is circular types of basin that we have studied this one. And this is the second is rectangle. And third one is this one hopper bottom barred flow, your hopper type of sedimentation tank, right? So depend on the application because sedimentation tank is uses are very large in everywhere in industries also in seaways also everywhere it is useful. So that's why. So here if you see this is a rectangle type of clarifier mechanism will be similar. Here they have used a chain pulley or types of structure rather than using a scrapers, right? Because scrapers cannot rotate, it's not a circular tank, it's a rectangle tank. Then other mechanism they have to put it. So it's a pulley rope mechanism, kind of chain pulley mechanism, and then scrapers can be there are the sprockets and driving gears, and it can remove the sludge and all the scum also can be removed. Okay. This is the hopper type, hopper bottom up bar type. So here this is a side view actually, so it will be in a hopper shape. So here mechanism is also different. We have to clear the deposited in the interior wall, and then the scum also we have to remove it. So these are the specifications given for this. Pure water taken by draft channels. Sludge out pipe is used to take out the sludge from the tank. Overflow rate generally taken as 2000 liter per hour per meter square. Detention time provided for 3 to 4 hours. Typical dimensions of sedimentation tank is given here. The circular basin diameter should be in this range. Typical, you can take it there. Depth, you can take it in that range. Bottom slope, you can provide 60 to 160. In a Ministry of Urban Development, CPHEO, as I told you, Central Public Health Environmental Engineering Organization, Ministry of Urban Development, and we have water supply and treatment manuals. We have a sewage treatment manuals also. They keep revising the manuals. Through this, all the standardization, standard effluent discharge limit, standard designing limits for rectangular circular tanks, how much should be the diameter, how much should be the what material you can use it, how much overflow rate standards you can take it, all the standards are given it. We keep following through these manuals only. Okay. So for the design parameters, the surface overloading, the surface loading rate is the one important thing that we have to find out first. So Q by A, Q will be the volume with respect to time divided by the surface area will give you the surface loading rate. SLR sometimes or SOR, surface overflow rate. Sometimes we call it as surface overflow rate. Sometimes we call it as a hydraulic loading rate or overflow rate. So discharge divided by area, या flow rate divided by area actually. Area is the surface area only. Okay. जैसे हमने बताया था ना surface area कौन सा लेना है, इसमें बताया था कहाँ गया, ये वाला, ये surface area लेना है top वाला, not everything. Yeah. So we called as surface overflow, surface flow rate sometime. It is the volume of water applied in unit time per unit surface area. Here they have taken as plane area of settling tank. Okay, so that you have to be clear about it. So you can write it as a formula: volume with respect to time, volume per time divided by surface area. So Q by A you can write in short. Here V naught will be in upward direction and Vs will be in downward direction. Vs is the settling velocity of particles. V naught is the velocity of, or we can say the what we called as the flow of water that we have it. Okay. So surface area you can measure it. Surface area you can take it from there. Then divided by V naught. And rectangle sedimentation tank if it is, then area will be different, height into width. So Q divided by height into width. If it is a circular area, then pi by 4d square. Based on this, you have to check it. Okay. Surface overflow rate SLR, you can get it like this. There is a time of horizontal. We can write it first. This is the first number. There are the 4 5 parameters. While you're designing or sedimentation tank, you can write it. So you write the surface overflow rate first. Sometimes we call the SOR, SLR. All are the similar name. Okay. So you don't need to get confused about it. If it is a circular tank, then pi 4 d square. If it is a rectangular tank, the top of the area, surface area. So time of horizontal flow will be T naught. You can represent this will be L divided by V naught. Time of horizontal flow, water will flow in horizontal direction. And how much length the water will cover? Throughout the tank length only. So what is the length total? L divided by V naught, you can write it. And V naught is this one. V naught is equal to Q by AS. And what is AS? L into B. So if you go like this, so LBH divided by Q, you will get it. Time of horizontal flow. This is second. So volume of velocity of we can say the Vs should be greater than V naught since the particles are captured from the water. Okay, that is important condition for just a minute. It is clear V naught about it. Yeah. You write it this one. For capturing the particles, the Vs should be greater than V naught, then it will. If Vs is greater than V naught, particles captured. Vs is less than V naught, then particles escapes. Number third is the detention time or hydraulic retention time. Don't get confused. HRT or detention time both are similar, both are same thing. It's the average theoretical time taken by water to travel from inlet of the settling basin. Detention time we generally take for the water supply sedimentation tank with the coagulation 4 to 8 hours. Okay. If you are adding coagulant, retention time will reduce. So volume of settling tank. Volume of settling tank, how you will calculate? Flow rate multiplied with detention time. Q into dt, you will get the value of volume of detention time. So you write it all these things 1, 2, 3, and 4. Okay. And fourth one is the flow through velocity. We are right now designing a sedimentation tank. Okay. So these are the hydraulic parameters that you have to note it down. Flow through velocity for the horizontal flow velocity. For the rectangular settling, the V horizontal velocity will be equal to Q divided by cross-sectional area, Q divided by B into H. You check here. See, B into H is different and surface area is different. Surface area is L into B. And this is different, B into H, width into height. Okay. So flow through velocity, the horizontal flow velocity will be Q divided by B into H. And what was the surface overflow rate? Q divided by rectangle area. What was the area for it? Surface area. Okay. So this is the thing. Now, so Vf is the speed which water travel from inlet to outlet of settling tank is known as the flow through velocity or velocity of flow. For the rectangle settling, Vh will be Q divided by cross sectional area. So Q by B into H. Question number 1. Cross sectional area, if you want to find out, then Q divided by BH. And VH value as a standard value, how much you have to take it? 0.2 to 0.9 meter per minute. 0.3 meter per minute you can take it. Length of the settling basins, you can define it. Length L, it is VH with there. Length is equal to length of LH is equal to VH into retention time. That also you can note it down. Now we'll come to the we can say the wear loading rate, WLR, very important WLR. Amount of water overflow per unit length of the tank it is. What is wear loading rate? Amount of water overflow per unit length of the tank. Okay. So this is also Q divided by the length of the wear. So Q divided by length of the wear is B. So Q by B will give the wear loading rate. For the rectangular For the circular settling tank, it will be Q by pi d. Okay. For the rectangular tank, it will be B only. There are the three cases again. If Vs is greater than V naught and dP, if Vs is very much larger than V naught and d is greater than dP, particle diameter, okay, velocity of flow, velocity of sediment. Sediment is nothing but all the particle velocity. If Vs is less than V naught and then d is less than dP, there are the three cases can possible. If velocity is greater than the sediment velocity is greater than the velocity of flow, then the particle cannot be captured. So there are the conditions in this. Now the next thing is efficiency of particle removal. So these are the important things we have written it. These are the concepts. Why are the concepts? Any concept directly. See the concept is make your own. I will share this PPT to you. Try to study in such a manner, so it will be easy to revise the thing. Right? So the particle efficiency, the factor, where it is dependent on the law, it is and would depend to say that goes to like. And now the overall efficiency of all the particles, how you of the divided by V naught. Okay. So overall removal efficiency of the we have reached this sedimentation tank, rectangular, circular, we have discussed. Surface area SLR we have discussed. Settling velocity, value of the settling tank, discuss. So WLR we have discussed, Q divided by length of the bear. If it is a circular tank, then Q divided by pi into D. If it is a rectangular tank, what will be the wear loading rate? Q divided by B. If it is a circular tank, then Q divided by pi into D will be the wear loading rate. You studied till that. Okay. Yeah. Now. So generally we take a 60 to 70%. Some of the numericals are given on this. Then if you want to find out the overall efficiency, you have to use this formula. Okay. For the 100% removal of the particle from the water in settling, just a minute. Vs is equal to V naught होना चाहिए, right? If the sediment velocity is equal to velocity of the flow, then the 100% efficiency is there for the removal of the settling particles. If Vsi is greater than V naught, then the detention time will be L divided by V. Down here, which is in subconductor efficiency, L divided by V. Particle time equal to the time and the detention for. So simple numerical we will do it. Question number 1. Q is given 10 to the 5 Q max. Vs is given 10-20 seconds. Surface area you have to find out. So surface area, how you will find out? Q divided by V naught. So that's why you can get the answer. Q by Vs. So question number 2 is given. Specific gravity is 2.65. Gamma is 0.89 mmQ per second. And then you can convert it into 10 to the minus 6, then you will get it in meter square per second. Unit गलत लिखा है, mm square per second it is. This is okay. D is equal to, we are getting the diameter of the particle is 0.03 mm, and convert into meter and apply this formula. Vs is equal to Vs, you can get it through this the Stokes equation. And then overflow rate, they have given 1200 liter per hour per meter square through this also. Eta you can calculate it here. Eta is, this is the equation, Vsi divided by V naught, multiply with 100. So V naught is 1200 liter per hour per meter square. I will read the question and you will understand. I will circulate these questions to you with the solutions. You just solve it, okay? It will be easy to understand. In 2 hours, we cannot discuss everything. So, okay, still I have put some efforts to you just so you can get the basic understanding of these questions. Okay. So this equation we have discussed. This is a Stokes equation earlier. And then if you want to get the settling velocity, that is V naught, you will get it height of the settling tank divided by the time, or finally that overflow rate, this you are getting it Q by A generally. And if you want to get the detention time, that is V upon Q, volume divided by flow rate. So there is a question given here. The water treatment plant has a flow rate of 0.6 meter cube per second. The settling basin at a plant has an effective settling volume that is 20 meter long, 3 meter tall, and 6 meter wide. Will particles that have a settling velocity of 0.004 meter per second be completely removed? If not, what percentage of particles will be removed? So what is given here? V naught is greater than Vs. Settling velocity and velocity of a particles is given. So V naught is greater than Vs here. How big would be the basin need to be remove 100% of the particles that have a settling velocity of 0.004 meter per second? If V naught is equal to Vs hoga, then 100% removal efficiency will take place, right? So you just find out the V naught value first, Q divided by A, and area is 150, 20 meter long. How they calculate area, this is the volume actually, not area. This is the volume they have calculated. 20 into 3 into 6. 360 hours here then. Yeah. You calculate the area of this rectangular basin and then calculate the overflow rate, not surface flow rate, and then width is given 6 meter. 6 meter into length is equal to, you have to equate with the area. Area, how much you are getting it? L into B. B into H, sorry. So this is length. This is width. This is height. 6 into 3. What we are getting? B into H, right? Okay, then you just go through the PPT and we'll understand. I'm not wasting the time. Okay. Here they have given, I think, B is equal to Q by A, 0.6 meter per second they have calculated. And 20 into 6, L into B. So 20 into 6. So percentage removal BP divided by B naught into 100 they have calculated. Like this you can go for it. Now there's a coagulation, sedimentation added with the coagulation. As I told you, all the impurities are negatively charged. There's a zeta potential value they have to calculate here. These impurities are colloidal matter actually, and if you add a coagulant like alum or what we call ferrous sulfate and all that, then the chemical reactions will take place. So all the colloidal particles are negatively charged while traveling in the water due to the abrasion, wear and tear. There is a Brownian motion, all the particles are Brownian motion. Colloidal carries their charges on their surface. Most of the colloids are stable in water because of the charge they carry. So it is not easy to remove these colloidal substances. And as I told about the clarification, without you are going for plain sedimentation only, colloidal particles cannot be removed. The coagulant neutralizes the negative protective charge on the colloidal particles and allow them to coagulate. The chemical reactions will take place. Colloidal particles cannot be captured in the plain sedimentation. To remove the colloidal, accelerated sedimentation process is employed. And this is the zeta potential here. Colloidal stability is removed in zeta potential. So 4 pi, you write this equation, then I will move further. 4 pi Q into D by capital D. Q is the charge on shear force. Sometimes they ask a question on this zeta potential. So this is the how the chemical coagulation is taking place if you are adding a coagulant in this. So what are the chemical reactions? I will come for the further this diagram, then you will understand more. First, you write that what is zeta potential. This is the diagram for the zeta potential. Shortly, we are going to binding up, so don't worry. And within 10 minutes, we will stop the lecture. Okay, don't worry. Next lecture will come to me. Colloidal stability is measured in zeta potential, that is 4 pi into Q into D by capital D. Q is the charge on shear force, D is the thickness of the diffusion layer, capital D is the dielectric constant. There are the two forces acting between two colloidal particles. One is the force F, repulsive force due to the electrostatic potential. Number second is the force of attraction due to the van der Waals force. Okay, these are the two forces. Repulsive force and then force of attraction, that is called as a van der Waals force. Here it will be clear. You see there, there's a positive charge particles, negative charge colloidal substances. Positive, negative will make a zeta potential here, strain potential, zeta potential profile. There's a shear plane, and there are the two forces, repulsive forces and attractive forces. Particles with the negative surface area. There's a diffuse layer, and like this, the breakdown will happen in the colloidal particles, and they will be removed from the water. So how the particles will remove? There's a diffusion action taking place. Compact counter ion layers, closest particles approach, particles in suspension, polymer molecules, they will stick, and then there's the agglomerated solids. Actually, it has to be removed from the water, and then finally, and there's the electrodialysis process also. Through this also you can remove these particles actually. So cathode and anode like this you can provide it. Hydroelectrolysis. Okay, I will move further. How the impurities will stick, positive, negative will make the agglomerate. This process is called agglomeration. So this is the attractive energy force and there is a repulsive energy force. Electric repulsive and neutralization will take place finally. These are the van der Waals attraction. These are the repulsive force, and both will go in the direction. So force of attraction proportional to the 1 upon distance between the particle. The chemical substances that are added to carry out coagulation is known as the coagulant. Occur in 3 stages. Coagulation process occurs in 3 stages. One, the addition of the measured quantity of chemicals called as coagulant to water in their thorough mixing that we do in flash mixing chamber. Number second is the formation of precipitate which coagulates and form floc on the top. As I told you, the chemical precipitation it is. Number third is the sedimentation, the physical sedimentation. The first stage is the flash mixing, where the high turbulent mixing of coagulant used water passes through wear and orifice plate. First stage. Sometimes mechanical stirring is also there. There are the mechanical strainers, and there is a constant stirring operations will be happening, and we have to mix it in flash mixing chamber. These coagulants should mix properly. In the second stage, the formation of the precipitate, as I told you, the coagulant, a floc generation. The third stage, the building of the same process, the building of the particles of flocks to a larger size, and either they can generate a flock on the top or they can sediment at the bottom of the tank. Okay. After adding coagulation, the following mechanism occurs, that is the colloidal stabilization. Number first is the compression of electronic double layer. Number second is the adsorption or change of neutralization. Number third is the sheaf coagulation. Yeah, entrapment and precipitation. And fourth one is the interparticle brazing. That much of knowledge is not required, but you must understand what are the common processes will be happening. Chemical precipitation and physical sedimentation. Okay. What type of impurities will be removed through the sedimentation added with coagulation process? Animal and vegetable matters, phytoplankton, mineral matters, clay and other colloidal soils, organic coloring matters, particles in fused solution and particles in colloidal form, bacteria and viruses, complex mixture of colloidal and dissolved organic compounds derived from seaways and industrial effluent. These are the impurities which can remove through the coagulant added with sedimentation process. What are the common coagulant that we are going to use it? Alum, aluminum sulfate, ferrous sulfate, ferric sulfate, ferric chloride, sodium aluminate, chlorinated copras, and the lime soda that we can use it, magnesium carbonate, and polyelectrolytes. Polyelectrolytes work as a coagulant add actually. It makes the process more faster. If you are adding coagulant, the regular process will take. So if you add the polyelectrolyte, it helps as a coagulant add actually, like catalyst, right? Sometimes in chemical reactions we use catalysts, no? The same way polyelectrolytes will work. Affecting factor of coagulation, the type of coagulant use, doses of coagulant, characteristics of water, type and quantity of suspended matter, temperature of the water, pH of the water, time, violence, and method of mixing. These are depending factor of the coagulation. This is the coagulation, how you decide the coagulant doses in a laboratory. The coagulant doses are decided based on the jar test method. There's a chemical conditioning, addition of the chemical to the water. What are the doses, how much mg per liter you have to add it, that you have to decide it. So there is a jar test in your laboratory, environmental engineering laboratory. There's a stirrer on the top of this, and a stirrer will rotate with the constant RPM and with respect to time, and coagulant you will add it. So in that way, how much precipitation and physical sedimentation is happening, based on this doses has to be decided. Okay. Flocculation, physical conditioning, growth of the particle; coagulation, chemical conditioning; sedimentation, settling of the flocculant. So these basic terms you must understand. Jar test is required to find out the optimum doses of coagulant. The minimum doses and maximum removal capacity you have to decide it. There are the rapid mixing and slow mixing of stirrer. If it is a rapid mixing, 1 to 3 minutes, you have to stir this coagulant in a water, having a RPM 100 to 120 RPM. Uniform blending is required for the physical conditioning. Physical conditioning means we are talking about flocculation. Slow mixing is 20 to 40 minutes, 1 to 3 RPM. Allow the flock so form to settle down by keeping the content of the jar quiet, and for a period of 30 minutes to 1 hour. Jar test. And this is the equation. Optimum doses will decide based on this graph. Turbidity remaining, and this is the pH level, and this is the optimum dose. They have decided optimum pH is 6.3, and doses will be decided. And 6.3, this will be the doses will be decided. Okay, the optimum curve we have to. This is the design of flocculators, the various parameters. We do not have time. The next class will continue these things. Okay. There's so much to study. Yeah. The next class will proceed for it. Okay. We don't have time now. Yeah. So we are going to bind up the session for today. I hope you understand something. Okay. If you have any questions, you please ask, or I'll lead the class. It's already 6:23. I will share this PPT to you. Okay. Then after that, filtration and disinfection is required for the water supply and treatment engineering. it will be over. And the wastewater portion, I will just talk about the unit operations for the tertiary treatment and biological operations. That's all. For that part, then the water and wastewater engineering will be completed. Air pollution and solid waste, I will take one class sometimes. Then our portion will be completed. So thank you for joining the class. We'll bind up the session. Total 17 were there. Now 13 are there. Okay. Okay. We'll leave the class. Okay.